Okay, guys, day 5, step functions and piecewise functions. So remember, the first day we did limits all by looking at the graph. As x goes to some certain value, what does y approach? And then each one of these days previous to today, we've been doing it algebraically. And we'll do that as well, algebraically with step functions and piecewise functions. But let's first review yesterday. Here's your challenge for today. So we can pause and you can do it. And yeah, there's no rolling of the die. But we'll just do this anyway. So you can pause and do it if you want. So I'll recap with you. Limits to infinity. So if we're doing limits to infinity with a polynomial function, you're just going to use your end behavior rules. Is it positive even, negative odd? But this is a rational function. So when it's a rational function, we want to use our horizontal asymptote rules. So let's compare n and d, which is the highest exponent in the numerator with the highest exponent in the denominator. So here we go. So we can clearly see here that we have n is greater than d. So there is no horizontal asymptote. So we'll take 4x to the 6th and 7x cubed, and we'll just reduce it to get 4/7 x cubed. So now we have positive, odd. Positive, odd is righties up. And then they want me to take the limit as x approaches negative infinity. So that means I'm going this way. So if I'm going this way, where's the graph headed? The graph is headed, oops, I circled the wrong one. Okay, if x is going to negative infinity, we're heading this way, and the limit is negative infinity. Let's do the same thing over here. Limit to infinity again with a rational function, right? We can see this fraction. So we're going to compare the highest exponent in the numerator with the highest exponent in the denominator. This is another example of n is greater than d. So we'll simplify. We get 1/5 x squared, which is positive even, which is up. So it doesn't really matter which infinity I'm going to. The answer is going to be positive infinity, but we'll do it anyway. I'm headed towards negative infinity. That's this way. So the graph is headed towards positive infinity. There we go. All right, so that's just a little recap of yesterday's lesson. Okay, so let's look at today. So here's 2 examples of piecewise function. Remember, piecewise function is exactly that. It's different pieces. You can see that this one looks like maybe it's part of a parabola, and you can see that this one is part of a linear function. Here we can say that the limit does exist because as I approach from the left and I approach from the right, I land in the same spot. So the limit does exist. But what if the piecewise function looked like this guy? As I approach from the left, I'm reaching a y value, and think of it as a height. I'm reaching a y value of some value here. But as I come from the right, riding along this function, I'm much higher. So I'm not approaching the same y value. So therefore the limit does not exist. So that's just a little picture of a graph of when a limit would exist and not. But we're going to be doing it on algebraically. So it says you must get the same y value for each piece. So find the left and right hand limit. Okay, so we're just going to approach from both sides for a piecewise function. And I'm going to show you how to do that. All right, so here's our first one. We can tell it's a piecewise function, right? We have 2 linear functions. So let's approach from both sides. So I'll separate this. We'll take the limit as x approaches 2 from the left, and we'll take the limit as x approaches 2 from the right. So you are supposed to put the f of x in here, but I just don't have much room. Okay, so let's see what happens. First, we have to go to the correct domain. So for the first one, x is approaching 2 from the left, so that means I'm a little bit less than 2. So if I'm a little bit less than 2, that's this domain. So I'll take my value of 2 and just replace it in. So 2 times 2 is 4, plus 1 is 5. So I get 5 for this left-hand limit. Now let's do the right-hand limit. So I want to find the limit as x approaches 2 from the right. So that means I'm a little bit bigger than 2. So if I'm a little bit bigger than 2, this would be the domain I fall in. So plug 2 in, and I get 5 again. Okay, so these guys are the same. So the limit does exist. The limit is 5. What does the limit mean? It's just the value that y is approaching as x approaches some value. So as x approaches 2, y is approaching 5. And the limit exists because it is the same. All right, let's do the next one. Same thing, you can tell it's a piecewise function. The first part is linear, and the second part is quadratic. So we have to separate it and approach from both sides. So the limit as x approaches 2 from the left of f of x, and the limit as x approaches 2 from the right of f of x. Okay, so if I want to approach 2 from the left, that means I'm a little bit smaller than 2, so that's this domain. So take 2 and replace it in, and we get -4. Now let's do the limit as x approaches 2 from the right, so that means that it's a little bit bigger than 2. So that's this domain. So let's plug in 2, every place we see an x, carefully, and we should get -3. Now these two guys are different. If they're different, the limit does not exist. There is no same y value that it's approaching. So you can say DNE, or you can use that symbol. All right, next. See, at least the good part is that you guys are going to be able to have all your notes out when you're taking tests for me. I won't be able to stop you. So as long as you're watching these videos and taking good notes, you should be able to do a good job here. Okay, next, fine. So I have several parts to this one. So we have part A, part B, and we're just going to use the same piecewise function. Okay, so let's take the limit of f of x as x approaches a half. So we separate it again. The limit as x approaches 1/2 from the left, and the limit as x approaches 1/2 from the right. Okay, so technically we should put the f of x on there. All right, so let's just find the domain. So for the first one, the limit as x approaches a half from the left. So I want to be a little bit smaller than a half. So I think that would be this domain right here. And the answer is right here. It's just a constant function of f of x equals 8. Right, like y equals 8, so it's a horizontal line. Let's approach x approaches half, but from the right, so a little bit bigger than a half. But we can see that it falls in the same exact domain right here, right? X is greater than 0, but less than or equal to 1, so it comes from the same one, same domain. So it's going to be a half, it's the same, so therefore the limit does exist, it's 8. Okay, let's chart part B. So the limit as x approaches 2 from the left of f of x. I need more space. And the limit as x approaches 2 from the right of f of x. All right, so let's just find the appropriate domain again. So if we're looking for the limit as x approaches 2 from the left, that means we're a little bit smaller than 2. So that would be this domain. And we would get an answer of 10. Okay, so now we're going to approach 2 from the right, so a little bit bigger than 2. So that would be this domain, right? X is greater than 2. So I would get 12. So they're different. So the limit does not exist. Alrighty, looking good. All right, 4. Okay, limit, another piecewise function. Let's separate it. X approaches 2 from the left, and the limit as x approaches 2 from the right. If you want to pause and try this one yourself, you can. You could do 4 and 5 yourselves, and then check back with me and see if you get it right. Okay, so which domain is x coming from the left? So a little bit smaller than 2. So that's this domain. So if we plug in 2 minus 1, we do get 1. Second part, x is approaching 2 from the right, so that means it's a little bit bigger than 2. So plug in 2. 2 times 2 is 4, minus 3 is 1. They are the same, so the limit does exist, and the limit is 1. Okay, same thing. You can try this next guy if you didn't already. So pause it if you want, or set it up and then pause it. The limit as x approaches 1 from the left, and the limit as x approaches 1 from the right. Okay, so which domain does this fall in? X approaches 1 from the left, so a little bit smaller than 1. And if we replace in the number 1 right here, we get 4 minus 1 squared, so we get 3. And then x approaches 1 from the right, so a little bit bigger than 1. So put in 1, 3 minus 1 is 2. So they are indeed different, so does not exist, or you can use the symbol. Okay, so that's it for limits of piecewise functions. Now we just have to do limits of absolute value. Okay, so we're going to have to think logically about this, and we have to remember some things from the other day that I've been trying to review with you. So let's just recall again what the absolute value function looks like. Absolute value function is a v, but we have little transformation rules going on here. So this graph that we have, x minus 2, is going to be a horizontal shift to the right 2. So that's going to be this graph right here, the red one. Now, we want to separate it, right? We still want to evaluate from the left and from the right. So we're going to create an absolute value. We're going to take the absolute value function and turn it into a piecewise. So remember if I was separating it and it was just absolute value of x, it would become x and negative x. Well, I do the same thing, but it's a binomial. So it's going to be x minus 2 and the negation of x minus 2. Now the domain, look at the domain. The domain for this one was x is greater than or equal to 0 and x is less than 0. That's because the vertex was right here at the origin. Now our vertex is over at 2. So we're going to say x is greater than or equal to 2. You always just use whatever the vertex is. And x is less than 2. Okay, so you first create your piecewise function, which we just did. And now we'll do the same thing we did on the previous slide. We're going to evaluate from the left and from the right. So we'll take the limit as x approaches 2 from the left of f of x. And I need a little more space, but I still want to see this. And we'll take the limit. Oopsie. Oh, all right, I need more space. All right, well, I think we saw the picture. Okay, the limit as x approaches 2 from the right of f of x. And now let's just plug in the appropriate domain, just like we have been doing. So the limit as x approaches 2 from the left, so a little bit less than 2. So that would be this guy. So let's take 2 and replace it in. So if I replace in 2, 2 minus 2 is 0. Negation of 0, there is no such thing, so it's just 0. 0 doesn't have a sign. And then we'll do it for this guy. X approaches 2 from the right, so a little bit bigger than 2. So that would be this one. Plug in your 2, and we get 0. Because these guys are the same, the limit does exist. Oopsie, I meant to just say same. So the limit is 0. And if you think about it logically, isn't this always going to happen with an absolute value function? If it's just a normal absolute value function, right, and it's shifted over, that's always going to happen. But, you know, we're going to do some tougher ones where it's not just a regular absolute value function. All right, so let's try 7. All right, so let's separate it. Same thing. Remember what the first step is. Create a piecewise function. When I create the piecewise function, just like, and I know I keep bringing this back, but I just want you to, be able to relate. When I gave you just a straight up absolute value, you guys created a piecewise function that was x and the negation of x, where the domain of x is greater than 0, greater than or equal to, and x is less than 0. And we use 0 because that's where the vertex was. Okay, so let's keep that in mind when we go to this guy. So this is going to be x minus 3 over, keep the bottom, x minus 3. This one is going to be the negation of x minus 3. This is us taking care of the absolute value part. And then over x minus 3. Now the domain is using the new vertex. Well, think about the new vertex, 1, 2, 3. It's going to be shifted over here. Right, a horizontal shift. So the domain is going to be x is greater than or equal to 3, and x is less than 3. Okay, let's make a little bit of space for the limit. So again, just go back. I want you to remember what we're doing here. These are the steps. So the first step is to create the piecewise function, and the second step is to evaluate from the left and right. Okay, so let's take the limit. Now I covered it up, I can't see it. What were we taking the limit of? Okay. The limit as x approaches 3 from the left. The limit as x approaches 3 from the right of f of x. Okay. All right, so let's see here. X is as x approaches 3 from the left, so that means we're looking at to be a little bit less than 3, right? Now the problem is you can't just plug in 3 right here. You're going to wind up with 0 over 0. So let's plug in something a little bit smaller than 3. So we'll plug in 2. If we plug in 2 minus 3, because see how we can't include the 3. So if we plug in 2 minus 3 is negative 1. Also 2 minus 3 is negative 1. Negative divided by negative is a positive. But then there's a negative there. So this will actually wind up being negative 1. I just realized I switched up the negative and the positive, but that doesn't matter. You can set it up however you want. I don't know why I did that. Okay, so now let's approach from the right. So now I'm going to use this domain. And the same thing, if you put in 3 right there, you're going to get 0 over 0. So we can't figure out what the value would be. So maybe use the number 4. So if I put in the number 4, 4 minus 3 over 4 minus 3, I get 1. So we can see that these guys are different. It does not exist. And that's it. So those are the 2 that you need to know for absolute value. Now, the rest of this lesson is just like review that I would have done at the end of class. When we finished the lesson, I would have let you just practice a little bit. So we can just practice a little bit together. So let's see what we got here. All right, so this is practice with c over 0. You can see that this one is a 2-sided limit because x is approaching 4. This one, too, is a 2-sided limit. X is approaching negative 3. Now, this one is a 1-sided limit because x is approaching 4 just from the left. Okay, so what's our first step again? Our first step is just to replace in. So if I replace in 4, because we might get lucky and get an answer. If I plug in 4, I'm left with 8 over 0, so I'm left with a constant over 0. Remember what that means. It means there's a vertical asymptote. So if there's a vertical asymptote, that means that my answer is going to be positive infinity or negative infinity. I'm going to be pushed high up in the air, or I'm going to be pushed low in the air. So how do we figure it out? We approach from both sides. We take the limit as x approaches 4 from the left. We take the limit as x approaches 4 from the right. All right, so let's see. So if I'm going to approach from the left, I'm going to use something a little bit smaller than 4. So maybe I'll use like 3.9. So if I put in 3.9 in here, 3.9 plus 4 is a positive. But if I put in 3.9 in here, think logically. If you put in 4, 4 squared is 16. 16 minus 16 is 0. But if you're going to square something smaller than 4, then it's going to be smaller than 16. So I'm going to get a negative on the bottom. So a positive over a negative gives me a negative. Now let's approach from the right. So I'm going to put in something a little bit bigger than 4. So if you put in something a little bit bigger than 4, I have a positive, and something a little bit bigger than 4 squared minus 16 is going to be positive. So we can see that these guys are different, so it does not exist. Okay, let's do another one. So now we're going to find the limit as x approaches negative 3. Always plug in right away. If I put in negative 3 here, we're going to get 1 over 0. So again, we have a constant over 0. There's a vertical asymptote. When this happens, the answer to the question is either going to be positive infinity or negative infinity. Or, I mean, it cannot exist as well. So we have to separate it, and we have to approach from both sides when we have c over 0. So we'll approach negative 3 from the left, and we'll approach negative 3 from the right. I'm not going to squeeze f of x in there. Okay, let's check it out. So let's come from the left of negative 3. So if I put in a number, and you should notice, again, look at this. It doesn't matter what the heck you're plugging in for x. After you square it, isn't it always going to be a positive number for both situations? So therefore, they're the same. It's going to approach positive infinity. All right, we got 2 more. This is long. Okay, 2 more. So this one, we're just approaching 4 from the left. If we do put in 4, we do get a constant over 0. So we do know, oopsie, we do, what is going on here? Okay. Come on. Oops. Let's try again. Okay, we do get a constant over 0, which means there's a vertical asymptote, but they want me just to come from the left of 4. So we're going to put in like 3.9. So look, I'll just write it out a little bit. So like say we put in 3.9. You have a positive on the top, you have a negative on the bottom, or just whatever, a negative on the bottom. So this is going to be negative, so it approaches negative infinity. Okay, last one. So the limit as x approaches negative 4 from the right. So if we plug in, so this is a one-sided limit. So remember, you're supposed to first just plug right in and see what happens. So if I plug right in, I'm left with the inside is going to be 0, square root of 0 is 0, times 2 is 0, and I actually just get a straight up answer. If you looked at this graphically, this would be a shift to the left. There is a vertical stretch involved too, but that doesn't affect what it's going to approach. So if we approach negative 4 from the right, you can see we do land at a height, right, a y value of 0. Okay, guys, that's it. So for this one, I think I gave you delta math homework, but the delta math homework, I don't think it's going to be on this piecewise and absolute value stuff. I think it's just some practice from the other days because I didn't exactly like, I think, what I found on there. So I don't want it to be confusing. All right, that's it. Hope you are enjoying limits and understanding them. All right, bye.